Continuing on here, let's graph slope and intercept form with our parameters. Now, in the first question, we're going to graph the linear function with a slope with an m of -3/2 and a y-intercept of 4. So that's my b. Remember, b is your starting point. So we start 4 up on our graph. 1, 2, 3, 4. Put a point. Always on the y-intercept with slope-intercept form. Now remember, only one of these numbers is negative when you have -3/2. I always like to think of the first number as negative, so that means I go down 3 into the right 2 because right is positive. So at this point, I'm going to go down 3 and over 2. And from that point, I'm going to continue to go down 3 and to the right 2. And then I'll draw my graph. I didn't draw that very well. I'm going to redo that. There we go. Now you could have gone, just to show you, I could have gone up 3 into the left 2. So if you run out of room, remember -3/2 is the same thing as 3/2. Where you put the negative doesn't matter. You just want to do it accurately. Not both of them. Only one of them is negative. Now on our next one, I want to rewrite that form like we did on the first page in slope-intercept form. So I want it to look like y equals mx plus b. So the first thing I'll do is I will subtract 12x from both sides. Like I said, I like to write my x first. So to have it in y equals mx plus b, I'm going to rewrite this next to the graph. So I'm going to say, bring down my -3y equals -12x plus 18. So we'll divide everything by -3. So y equals -12 divided by -3 is 4 minus 6. So I'm going to start here with my graph by going down 6. Put a point on your graph down 6. Now my slope isn't a fraction. So how do you write 4 as a fraction? Well, it's 4/1. So that means I'm going to go up 4, 1, 2, 3, 4, and over 1. Up 1, 2, 3, 4, and over 1. I could do that forever, but I can draw my line through those points. Off a little bit there. I want to keep it close enough. Now, our next example, I want to graph y equals 2. We did this on a previous lesson. You just go up 2 and draw a horizontal line. In slope-intercept form, this is the same as y equals 0x plus 2. So notice what happens here. I go up 2. I go up 0, which means I don't go up at all and just go to the right 2. And I could do that forever. And that's where I get my line from. We have our last application problem here. Let's take a look at this together. It says, the number of online shoppers in the United States can be modeled by this equation, where y represents the number of millions of online shoppers in the United States, x after 2010. So that's kind of important. X is not the years, it's the years after 2010. We want to estimate the number of online shoppers in 2020. Well, I think what we'll do first is we'll get this equation in slope-intercept form. So we have negative 5.88x plus y equals 172.3. So now, to get y by itself, we just add 5.88x to both sides. So our new equation is y equals 5.88x plus 172.3. Now, x is the year since 2010, so in this problem, x would be 10, because from 2010 to 2020, x is 10. So now I'm going to rewrite my equation. I'm going to replace x with 10. I'm not going to graph this one. I'm going to do it algebraically, because notice they're kind of ugly numbers. Now I'm just going to simplify that and really evaluate my function. So 5.88 times 10 is 58.8 plus 172.3. I could do that by hand, but I'm going to use my calculator. So I'm going to say 58.8 plus 172.3. And we get 231.1. So I'd say y is the number of millions of online shoppers. Since it's an application problem, well, it's a complete sentence. I'd say there were 231.1 million online shoppers. And there we have it.